For this video, we will be reviewing second derivative test. Charot, walang energy si Shawn. Okay, for this video, we will be talking about second derivative test. Yay! But again, before we proceed, remind ko lang ulit kayo na sa kahit anong bahagi ng video na to ay pwede kayong mag-pause for a while. If you prefer solving the problem first before I fully discuss the solution, or whenever you need some time to breathe, no? If may hindi man kayo magets, so you can use the pause feature here. Okay? For the first item, we are asked to find and classify all critical points of the function f equal to x raised to 4 plus 3y squared minus 2x squared minus 6y plus 5. Okay? First thing, ako kasi kapag ganito, ini-inspect ko na agad kung anong klase ng function yung f. The function f is a polynomial function in x and y, no? It's a polynomial function. So, ibig sabihin, yung first order derivatives ng f would exist at any point. Okay? And next, the critical points of f are the solutions to the system given by this. So, yung derivative ng f with respect to x is 4x cubed minus 4x, tapos we equate that to 0. And next, the derivative of f with respect to y is 6y minus 6, then we equate that to 0. Tapos yan na yung mga equations ng system na yan. So, let's try to solve the system. Look at the first equation, no? So, from here, you could see that 4x cubed minus 4x is just equal to 4x times the quantity x squared minus 1. And factoring this further, we have 4x times x plus 1 times x minus 1. So, ibig sabihin, yung values ng x ay x is equal to 0, negative 1, and 1. Now, next, let's look at the second equation naman. So, we have 6y minus 6 equals 0, no? But, i-manipulate natin yung left-hand side. I mean, yung 6y minus 6. This is just equal to 6 times y minus 1. So, this means that for this to be 0, y must be equal to positive 1. Okay? So, again, bakit naging x equals 0, negative 1, 1, and y is equal to 1? It is because kinukuha natin yung values ng x and y so that the given expressions here ay both equal sa 0. And we have it here, no? X equals negative 1, 0, 1, and y equals 1. So that means, ang ating mga critical points ay negative 1, 1, 0, 1, and 1, 1. Now, let's compute the second order derivatives of f. First, the f sub xx, we have it equal to 12x squared minus 4, while f sub y is just equal to 6. Okay? And lastly, f sub xy is just equal to 0. Now, it's time to make a table, and we just have to recall that d, the big D, is equal to the expression given here. Okay? So, as you can see, applying the second derivative test is a systematic method. Okay? So, practice is really advised in this topic. Now, let's fill this table. So, what is f sub xx at negative 1, 1? Is just equal to 8. Correct. How about at 0, 1? It's equal to negative 4. Correct. Lastly, how about At 1, 1, what is the value of f sub xx? Okay, good. It's still equal to 8. Now, let's solve for the d. At negative 1, 1, what is the value of d? You have to multiply f sub xx times f sub yy. So you have 48 minus the square of f sub xy. So it's equal to 48. Good. Next, what is the value of d at 0, 1? So multiply negative 4 and 6. We have negative 24 minus 0 squared. So it's equal to negative 24. And lastly, what is the value of d at 1, 1? It's equal to, correct, it's 48. Okay, now let's just have first a recall. So from a theorem discussed, if your d is bigger than 0 and your f sub xx is bigger than 0, this implies that at a certain point you have a relative minimum. Okay? However, if your d is still positive, yet your f sub xx is negative, at that critical point, you have a relative maximum. However, if your d is negative, this implies that at that critical point, you have a saddle point. Okay? Using these results, so let's now conclude. No? So, at negative 1, 1 and 1, 1, observe that d is equal to 48. No? And we know that 48 is greater than 0. With f sub xx both equal to 8, which is again greater than 0. So at negative 1, 1 and 1, 1, we have relative minimum. However, at 0, 1, since d is negative 24, which is less than 0, it means that at that point we have a saddle point. Okay? Hence, f has relative minima at negative 1, 1 and 1, 1, and has a saddle point at 0, 1. Next, for the second item, let g be a function whose partial derivatives are g sub x equal to y squared plus 2x minus 7, and g sub y being equal to 4x minus 7y minus 20. Now, we are asked to find all critical points of g, and we have to classify each point. Okay? So, similarly, in the earlier problem, the critical points of g are the solutions to the system given. Now, solving that, what we can do is, let's subtract g sub y from twice of g sub x. And this gives us 2y squared plus 7y plus 6 is equal to 0. So, let's now solve for the roots of the equation of the new equation. From there, we factor 2y squared plus 7y plus 6. So, we will be getting this expression. Okay? Now, from there, we can now say that y is equal to negative 3 halves or y is equal to negative 2. Now, note that if y is equal to negative 3 halves, this means that x is equal to 19 over 8. And whenever y is equal to negative 2, x is equal to 3 halves. So, the critical points are 19 over 8, negative 3 halves, and 3 halves, negative 2. Now, let's compute the second order derivatives of g. Okay? So, g sub x is equal to 2, g sub y is equal to negative 7, and g sub xy is equal to 2y. Again, let's make a table with d being stated in the slides. So, our g sub xy is equal to 2y, right? Completing the table, g sub xy is equal to negative 3, and for the second point, it is equal to negative 4. Okay? Computing for d, For the first point, it is equal to negative 23. And for the second point, it is equal to negative 30. With this, note that for both of the points, both D are negative. So it means that at both points, we have saddle points. Therefore, G has saddle points at 19 over 8, negative 3 halves, and 3 halves, negative 2. Okay, thank you. Till the next video.